As promised, in this video, I am going to finish up part 2. We finished in class and I left you one more example for z-scores. So on page 33, you have this exercise. If you didn't try it on your own, please do so. The ones we did in class are not as close to what you'll see on an exam as this is and the 2 from your homework. So if you're ready to go on, you've done this on your own, you just want to double check with me. We have these 2 friends who are both training for Boston. We got James and we got Rob, and they're training on 2 different loops. So James, he's on a hilly route. And then they tell us for general population, the time to complete this loop follows a normal distribution with a mean, which I'll denote with my little mu, of 167 and a standard deviation of 25. So I'll put my sigma there. All right. Rob, on his flat jogging route, well, the time it takes to complete this route also follows a normal distribution with a mean, or mu, of 143 and a standard deviation of 20. If it takes James 91 minutes, all right, so now we know James's actual time to complete this, and it takes Rob 86 minutes, who is in better condition? So the first question I like to ask is just, are these guys quick or not quick based on the general population? Because that gets us already thinking about the fact that quick, they're really fast, right? First off, they're training for Boston. If you know anything about running, that's an impressive feat. But second, their times are much lower than the actual finish times for the general population. So they are fast. If we want to go ahead and get our z-scores to be able to compare these 2 guys on their 2 different routes, our z-score is always going to be x minus mu all over sigma. So for James, and what we can do if we want to denote this for one person only is that we can put a little subscript in here. Let me erase that and just put a little. So we'll put a little j there to say that this is the z-score for James. Nice little shorthand. We'll take his observation. My husband is watching football, so you may hear him scream. Subtract off the mean and divide by the standard deviation. So this is going to show us how far below average in terms of finish times James is. And then we're going to do the same thing for Rob. So we'll have a z for Rob. Still start with his finish time. How far away from average is he in terms of standard deviations? All right, so bust out my calculator. Bloop. 91. As I said in class, you can do this with parentheses, but I find that it's actually less keystrokes if you just press enter. Looks like James is a negative 3.04. And Rob, oops, that's not right, is a negative 2.85. So now we have to answer the question, right? If this is a test question, it's usually about 5 points. Point, and then a point for choosing the right direction, and a point for at least telling me why. Because usually I'll say, explain your reasoning. So this support is good, but now we need to say who is in better condition. This is where a lot of students will accidentally say Rob because his time is, more, I guess, bigger. But bigger is not better in this case. We want further below 0. James is our better runner. In better condition. Because he finishes faster than average. Compared to Rob. And this is not the only way you could write this, obviously. You could also just say that, like, this is smaller than that, and we want to have smaller values because a smaller running time is better. You could talk about him being further below average, whichever you want to use. I liked using the word faster here, but it doesn't matter. Completely up to you.